Week 2, technically still kind of on week 1, but whatever. I know some of you are still working on the assignment. If that is the case, you might want to wait watching this, because I'm gonna show you my implementation of it, or rather, I will implement it live. But if you're stuck, feel free to watch. And also, at the end, we're going to talk about what's to be done for next week. We have a special live guest here today, Bete.
What's up?
Bete will tell me whenever I make a mistake. By the way, there was some confusion about the programming language to use for your implementation. We had this poll on Slack, which was about which programming language I should use for my implementation to show you. I'm fine with you using any language that you feel you're comfortable with. And by the way, unless you're really firm in C, I don't suggest you do it in C, because it's very easy to shoot yourself in the foot. But that's what you wanted me to do, so that's what I'm going to start doing. So let's take a look at the assignment again. Our assignment was to write a lexical analyzer that takes input like this and
I don't know if I can see your screen.
Oh, yes, I have to share my screen. Thank you very much. No, camera, screen share. There we go. Share. Can you see it now?
Mm-hmm.
Okay. So going back to the assignment. The objective is to take input like this and to basically split it up into individual tokens. Tokens being keywords like let and if and so on, operators like open, close, paren, equals, and so on, as well as identifiers and integers. So in this case, we have a keyword let and identifier a. Note that white space we just skip, we don't care about. So let's look at how an API for that would look, because we're going to be using the scanner in our parser later on. So the scanner obviously has to have some kind of an API. I'm going to call this compiler.h. This is kind of stupid. Hide. Okay. Create buffer, yes. So let's start with, this is like standard C stuff, where you have to make sure that you're not including a file twice. So we want a function scan that we're going to give it a context, and we're going to talk about that, because I don't want to use, I want to do it nicely, so I don't want to use global variables and stuff. So we'll save everything that we need globally, like, for example, the file that we're reading from in a context. And what does the function return? The function returns a token. Now, of course, we have neither defined context nor token. We're going to find the context. There might be other stuff that we want in there right now. We probably want to have at least a file in there. There might be other stuff coming. We'll look at that. And then what is a token? What do we need to know about a token? We need to know what kind of a token it is. And actually what I'm going to do is, just for simplicity's sake, I'm not gonna really differentiate between keywords and operators. I'm just gonna say this is the token let and this is the token equals. But so for those, I just need to know basically the type of token. But then there's other tokens, like specifically integers and identifiers that have some additional data. Namely, an integer has a value, which is a number, an integer, and an identifier has a name, which is a string. So I'm going to say I have a token type, is the type of the token. And then, of course, so this is C. Like I can't do stuff like subclassing or anything. So what I'm going to do is add a union. I'm going to call it V. And inside the union, I have either a pointer to a string, which I'm going to call name, sure, whatever. And also, so here's another thing. There is a header file called stdint, which defines integer types based on how large they are, and everything in Simplang.
Mouse.
Hmm?
Can you move those?
Oh yeah, it hides my mouse, but I guess it doesn't hide it in the video. And the integer I'm gonna call, I don't know, just I, whatever. And the union, in case you don't know what that means, it means that these two share the same space in the struct, in this struct, which means that I better not modify one and then access the other, because if I write into the integer, then the pointer will be bogus. And if I write into the pointer, then I'll get just a random integer. You can use this to, well, I don't want to get into it. Okay, so now we have the token type to define. Okay, what's a token type? Token type is going to be, we're going to make an enum, type def enum, token type t. And now here we have to enumerate all the different tokens, all the different kinds of tokens that there are. Specifically, I didn't want to do that. I'm going to do this. Replace this with nothing. So let's take keys away. And of course, and so next thing I'm going to do is I'm going to clear replace comma with new line. And then I'm going to do a macro. I'm going to call it token underscore comma. These are a few tokens. I'm also gonna, okay. What does the scan function return when we are at the end of the file?
A list of, or an array of the tokens?
No, I'm returning one invocation of scan returns one token.
Okay. Wait, what was the question?
What does the scan function return when we're at the end of the file?
Like end of file token, or? Yeah,
so that's one way to do it. We could say we have a special kind of token that's called eoff, for example. Another way to do it would be to, for example, have like another output argument that is that tells us is eoff. I'm not going to do it that way. I'm going to do it the way that Tay suggested. So here are all our keywords, I hope. And then we have all these operators. So I'm going to have to say open paren, all the grunt work, close paren. Then we have the assign operator, that's this here. And then I'm going to, for reasons that that will become clear later on. I'm gonna do the token not later on. The two character tokens I'm gonna do later on. Token not, token less, token plus, token times, and token negate, and then we still have token end. That's this one, and token or and token equals. Token end, token or, token equals. And I think those are all the tokens. No, those are not all the tokens because we are missing identifier and integer. Token integer, token ident. So these are all the tokens. So note of course also that we must only access the name if we actually have an identifier token, and we must only access the integer if we have an integer token. If we do it otherwise, then anything might happen. That's just how it is in C. That looks pretty good. Now we could write. And I have some other shit in there that I'm going to talk about later. I could now already write the driver for the whole thing, namely the thing that reads. Well, not quite. I need another function to initialize a context. So I'm actually gonna call it init. I'm gonna call it scan init, and it takes a context, and because I'm lazy, it's gonna take a file name, and I have to call this with the file that I want to open, and then I can scan. So let's do the following. If we get a number of arguments that is not 2, then fndef str usage simplang file exit. I can just return from main. So there's that. So now we have the file name in argv of 1. So I'm going to I'm just going to declare myself a context. And I'm going to scan init the context with that file name. And of course it should return a bool successful because the file might not open, but I'm not really going to do error handling. I'm just going to return true and assert that the file is correct or that the file opened. And now what I can do is I can scan. So I can make a loop and say token t token equals scan from the context. If the token type is token eof, then I'm done. Otherwise, now I have the problem, and this is maybe why my assignment is stupid. I need to know whether it's a keyword or an operator. So what I'm going to do, because all of these are really just numbers, right? So token eof is 0, token integer is 1, token ident is 2. That's just how enums work. All of these are numbers. What I can do is I can say token first keyword equals token let. I can say token last keyword equals token end. And of course, now I have to make sure that I never change the order of these, or at least this one is always at the beginning and this one is at the end. Also, I just found that I'm stupid because I have 2 ends So this is actually, let's call it logic end, and this call logic or. And then I'm going to make token first operator equals token open paren and token last operator. And by the way, we can totally have a discussion about whether open paren is an operator. I don't have a religious belief in that it should be or should not be. It's probably not an operator. So, but now what I can do is I can easily check whether what we have is, I'm sorry.
Token last operator is what?
Shouldn't happen. Token last operators token equals here. So all of these are operators. And now what I do is if, actually, another thing I'm going to do is I'm going to define an inline function. Static inline pool token is keyword. Actually, token type is keyword. Token type t. Return. What do I return?
If it's before or if it's between those, the token first keyword and last keyword.
Last keyword. Token first keyword. And I can do the same for operator. First operator. Last operator. So now that's good. So now what I can do is if token type is keyword token dot type, then what do? I print it. But again, keyword, what do I print here? I don't know. Let's call it, token keyword name of token dot type or token type keyword name, whatever. This is a little tedious. All of these are actually not, I mean, they're kind of important when you're writing the compiler and you're writing a real world compiler, which actually has to give reasonable error messages. Else if token type is operator not type. By the way, is the sound? Yeah, sound is coming through. Okay. If it's an operator, then we're printing operator token type, operator name, token type. And if the token type, token dot type equals token integer, then we're printing integer LD. I don't want to get into that either. Token dot v dot I think that was it. Else if token dot type equals token, then we're printing identifier. Is it identifier or ident? Ident. Then we're printing token dot v dot name. Otherwise, it should not happen. And that's it for the driver. Now all we got to do is also implement.
Does the cert come for free? Or do you have to for it?
Does it come for free? Oh, it is in assert.h. I have to implement token type keyword name of token type D and operator name. But these are going to be easy. Scanner include compiler.h. So this is what we have to implement. And then, of course, all this stuff. And again, we can use here the fact that, well, we're going to assert that token type is keyword T, and here we're going to assert this operator. Otherwise, bad things happen. We can here use the fact that the token types are integers, so I can index into an array that I'm going to call names, and I'm just going to use these names here. I'm too lazy to use a macro or something. Let and in if then else loop and end. And all I need to do is return what do I return? Names of what?
Of first index plus token type dot, or I mean T dot. Where's the index?
T is already the number.
Oh, okay. Plus T.
What plus T?
Oh wait. So it's like T minus.
Yes. T minus specifically
the first keyword.
Token first keyword. And same thing here. So except that here the names are, what are they? Open paren, close paren, assign, not s plus times logic end, logic or, and equals. All right, with that done, we can actually, well, not quite. We still need operator.
Assert again.
What?
Include assert.
Oh, yes, thank you. Now we still need to do this. We need to open the file. So I use a fix.file equals open file name R, open the file for reading, and I'm just going to assert to fix.file because I'm lazy. I'm going to return true. Okay, now finally we can write a scanner. So let's look at some source again. So here we have some source. So first of all, we will be reading characters by virtue of fget c. No, it's just get c. What? Why do you hate me? Let's see, there we go. No, fget c. What is the difference between fget c and but is a macro that expands in? Okay, we don't care. We'll just use fget c. So it returns the next character. Otherwise, it will return eof if end of file or reader occurs. Since we have to look ahead, for example, let's say we are scanning an identifier. So let's make this a little bit longer. Let's say we are here, so we see, oh, it's a letter, so I'm just going to start scanning letters and hoping that it's an identifier. I mean, in the worst case, it's an identifier. So I go ahead, I see a letter, I see another letter, I see another letter, another letter, another, and suddenly I see a plus. Now I can't just consume the plus, because next time scan is called, it needs to actually produce the token plus, right? So one thing I talked about this last time, we could use ungetC to go through the C standard IO stuff. But I'm actually going to always scan one character in advance. So I can just look at it and not consume it. So I'm actually going to add to our context the, where is it? Add an int, and it needs to be an int because eof might not be, it might not fit into a char. This is C, everything is weird. This next char, I'll look ahead. Now, of course, when I init the scanner, I need to read that first char, right? So I'm going to say context head equals fgetC from statistics file. Now, actually, I need to have, I also talked about this last time, I want to have two functions. I want to have a function, it's going to be static, that says, give me the look ahead from the context, obviously. And all that does is return to look ahead. So I don't really need the function, but whatever, I'll make it a function anyway. But also, I want to have a consume function that actually just reads the next character. So basically, it throws away the current look ahead. It says, okay. Oh. So what that is going to do is it's going to actually do this. So now I can say consume character. Okay, so finally, now let's say we are somewhere in our source. We are at the beginning. We're looking at an L, but the source could start with a space, right? So we are not actually at the beginning of a token. So one thing we have to do first is we have to skip over all the white space until we reach the first non-white space thing. So what do we have to do?
We have to, while
there's an isSpace function.
Oh yeah.
While isSpace of look ahead. From the context. So while we are looking at a space character, we consume, right? However, now note that we might also come to the end of the stream. So we better have some kind of a check. So this will return whether head is not eof, right? So as long as it returns true, we're good. That means I should also here bool whatever. Okay. I'm gonna assert. Okay. By the way, one thing you should never do is do a side effect that is necessary for the execution in the assert, because you can actually disable asserts for production builds or when performance is super important. And then the assert macro would just be completely eliminated and the side effect would never happen. You know what I mean? Mm-hmm. So, however, if not consume, then what do we do?
Right. or no, return.
We actually just have to return a token that is token type yoff. Okay. So now we know the file is not at an end. We are at a character that's not a whitespace character. So now what can happen?
Either see like an alpha, like what do you call this? Letter.
You could see a letter.
Or you could see like a number. Or you could see a special character.
Okay. Okay, so let's go through those one by one. If it is a letter, look ahead. Let's actually call, let's say int c equals head. So if it is a letter, what do we do then?
Right. So basically, we want to try to read a keyword or an identifier.
Okay. Identifiers are also allowed to start with an underscore.
Yeah, so I guess we'll just start with try to read a keyword.
But then you might also read an identifier. So you want to have two cases for keywords and identifiers.
I like to keep things simple sometimes.
But, all right, let's try it already. Let's see where we go. Okay, so we are starting with, we have a letter. So here's one thing that comes in now. We need to somehow aggregate all of these characters into a string. And you can do that in C by the way that you shouldn't do it, which would be allocating a fixed size static array, which of course is prone to buffer overflow, or it's an arbitrary limitation where you have to do a bounce check every time. And then you say, oh, I do not know about identifiers longer than, I don't know, 64 characters or whatever your limit is. Another way would be to do dynamic memory allocation, but then you have to check that you're overflowing, and then you have to resize again. Or you have somehow implemented this already sometime like 20 years ago, and then you can just use that code. So that's what I'm going to do. So I'm going to, and also, so here's the other thing. The other thing is that in C, you have to worry about freeing memory that you've allocated because it's not a garbage collected language. So another thing that we'll be using is this pools thing, where, which is also years old, which is just one growing pool of memory that you can very fast, very quickly allocate from, and that never frees anything, but you can free the whole thing in one go. And because we have plenty of memory, we're not going to run out of memory on this machine, but we still want to done because we want to be nice. We're going to be using this. So we also have to put this into our context. So we're going to amend the context by putting in a pool T. And this can be, this doesn't have to be dynamically allocated. Pools.h. And then what the scanner is also going to do is it's going to init the pools thing. And all of this stuff you have to do because C is very, very tedious. So I'm going to say pool init suffix pool, and I have to give it the address. And now that I've inited it, I can allocate from it, but also specifically I rewrote the dynamic string stuff so that when you allocate a new dynamic string, you have to give it a pool, and then it just allocates and reallocates within that pool. So to come back to this, in our scanner, we allocate a new bin string t is ds new from fix pool, and we say ds append char c. So I can append a character, and it's not going to overflow. I don't have to worry about that. And at the end, I can just get the data, and that's the finished string, and I'll terminate it and everything. Okay, so we got the first character. What do we do?
First, I want to ask, like, that ds append char.
Mhm.
That
Oh,
doesn't matter.
oh, I'm sorry. It has to take the ds.
Okay. Cool. So you read the first character, and I guess you look ahead and see. You basically look ahead until you find either a white space or a special character, and then basically construct this string, or keep on doing this until you reach a white character or a white space or a special character, right?
Why would you check for what the character that you're looking at is versus what it not is? Like there might be bogus
Okay.
in the, like there might be a
Yeah.
character that's not even legal in a
Yeah.
in a simplang file, right?
So then actually,
I mean,
might as well-
I've said before that only valid input is that the program needs to only handle valid input, but we're going to be, if it's easy to handle invalid input nicely, then we're going to do that.
Okay, so actually, let's just make it if is alpha or is like underscore, and then read the or keyword, and then we'll do the check at the end.
Oh, here?
Yeah.
Oh, you came around to my way of doing it?
Okay.
Okay. Okay, so if is alpha or it's an underscore. But okay, so
now we have to read, we have to consume, we're expecting to see a character or like a letter, a number, or a underscore.
character, digit, or underscore, yes.
Yeah. So
People often consume digits with numbers. It's one of my pet peeves. But two very different things.
but then character is weird because
Letters.
yeah, letters, digits, or underscores. So now if this is that, append there, and now we want to do another while look ahead or syntax.
So note, our look ahead is still the same, right? The look ahead is idempotent. It doesn't change. You can call look ahead 1,000 times and it's always going to give you the same until you consume. And we've already processed this character, so we can safely consume. But you have to do that if it doesn't, if it's not, if we're at the end of the file, we still have to produce the full thing. So what we can actually do is, what we should do is, we should say while we are successfully consuming and the look ahead is lnum, which means either a letter or a digit, or of course look ahead of from suffix, or the look ahead is an underscore, yeah, like nothing. Oh, yes, something.
Yeah.
D is append, namely the look ahead. Right. So at the end of the loop, we have either failed to consume a character, or the look ahead is not alphanumeric, and it's not an underscore. By the way, that brings us to another thing that we haven't thought about, namely, so let's just finish this and then I'll get to what we haven't thought about.
Can we
So
get like just a variable with only underscores?
yeah, you can have a variable like 5 underscores. So now we either have an identifier or we have a keyword, right? So what we can do is we already have this thing here. So we can say I'm actually going to say static token type T find keyword from name. I'm going to use the same table here, this one. Keyword names.
Does your DS library return constant chars? Then when we have to like cast that.
So you can implicitly convert a char into a const char, a char pointer into a const char pointer, not the other way around. So we should null terminate this, because now what we can do is for I equals 0, as long as keyword names of I is not null, but that's implicit. Now, if strcmp of name, comma, keyword names of I equals 0, return. Now we have to be careful, because we have to add first keyword, right? We have to do the inverse of what we did before. And if we didn't find it, I'm just going to return token eoff, because I'm lazy. So eoff is kind of like also, oh, we didn't find it. So I'm going to call it token type T. pt equals find keyword yes data. If we did find it, so there's two cases. If ps equals token eoff, then we did not find it in the keyword list. That means it is an identifier, right? So we're going to do token t equals token type identifier. What token? Oh, I didn't call it that. Token identifier. Okay. And then I need to say t.v.name equals ds data, right? Otherwise, oh, and I need to return the token. Otherwise, the token is very simple. It's tt token, right? So this case, we're done with this case. We got the We got keywords, we got identifiers. However, now what happens if the consume was not successful, right? We return the correct token, but the look ahead is now eoff. And now next time we start scan, we have to handle eoff here. So I wonder, I mean, I can do the simple thing. I can say if look ahead of statistics equals eoff, in this case, return. I need to make the eoff token again. I kind of want to have only one place where I have to produce that, but maybe that's token. Yes, I guess it is. Okay. Unfortunately, there's 2 eoff checks. I kind of don't like that. It would be nice if we had just one, but alas. Whatever, I don't want to think about that right now. What is more important is we still need to handle, we still have integers and we still have operators, right? So this case is done. If is digit, and we are reading an integer. So pretty much we can do the same thing that we did here, except that is digit and at the end we make a token T that is a token integer, and its value is A to L of S data. Which it might overflow, but we don't really care. And I don't know where A2L is in. Why have you forsaken me, Max? Oh, I see it. Okay. And that's that. Wow, boom. So what else is left? Special characters. Now we're gonna do another trick. That's where that comes in, the stuff that I did before. So we have the operators here, but I'm also gonna do a token first single letter operator equals token open paren, and last single letter open is negate. And I'm going to call this single letter operators equals open close assign not less plus times negate, right? Now, first of all, what I could do is I could rewrite this to use that, but I'm too lazy. But what we can do is there is a C function called stritcher, and stritcher will, given a string and a character, return a pointer to the first occurrence of the character in the string, or it will return null if the character does not appear in the string. So what I can do is I can say if stritcher single letter operators, comma, C, if we have found it, right, then I can make a token, which is token first single letter operator plus Okay. Now pointer arithmetic.
Plus the address of that single letter words minus.
And I might have to. Yeah, oh, I did it. So I can do pointer arithmetic. So I get a pointer to let's say let's look at the example. So let's say it's a not, right? So what I get is I get a pointer to this here, right? And I subtract the pointer, this pointer, from the pointer to the start of the string, namely to single letter operators, which is here. So I get the difference between these. And the difference is 1, 2, 3, which is basically the index into this array. So this is 0, 1, 2, 3. Right? And I add that to the enum, which I've made to exactly match these characters. Does that make sense? And return t. We're done. We've finished. Also. What's missing?
So if you're reading wait, what is C again? C is the
character.
Yeah. So if you're reading this and it's a double equals, this is still going to be true.
Oh, damn. Okay. Yes, you're right. I didn't think about that. The catch. So we have to actually, we kind of have to lie a little and pretend that this is not a single letter operator. And I think I put that into simplang specifically to make it a little bit more challenging. And I tripped over my own trap. So these are not all the single letter operators anymore. Whatever, let's just still call them single letter operators. And these are one of these is not a single letter operator. So to go back here, did I delete it? Yes, I deleted it. Okay, so, but also what we're missing is the consume. And I don't need to check whether it's eoff here because it's not actionable anyway. It's going to be checked the next time the scanner is called. And so now what we're missing is we're missing the and, the or. Okay, let's look at it this way. These two always come in pairs. So if C equals, if it's this one or C equals that one, then the next one must always be the same one, right? So we could actually say consume it and just assert, because we're super lazy, assert that the look ahead is the same as the character. So the assertion will fail if these do not come in pairs. And also note that even if we're at the end of the file, this will still fail, as it should. And then the token T is simply if C equals, if it's that, then it's token logic, and otherwise it's token logic or return T. Okay? So the only one that's missing is if C equals the equal sign, then we have two cases. And also I'm going to do assert false here. In this case, we have an invalid character. So we're just going to say screw you. And actually, I should use two different things here. There should be an error function, which tells the user that it's an error, and it should be an assert, and the same thing should be here. But let's actually do it. Let's say error. I hope there's no error function in C. Error. Whatever. Valid token. And let's call this error. Oh. False. Let's call it error assert. Okay. Assert. False, comma. So this will always not work. So basically, we're asserting that this is the case. If it's not the case, then we produce an error. And here, invalid character. Okay. So to go back to this, now we can still consume it, right? If the look ahead is, let's say if it's not the equal character, then it's something else. It might be eof. We don't care. We do know that we need to return the token assign, right? Otherwise, it is actually, we did get two equal signs, in which case we can consume the second one, and our token is, let's do it like this. And our token is token equals, right? And we assign and return the token. And I think we're done.
Error assert.
Yes, error assert. H. Static inline void error assert. Assertion. If assertion is true, we're good. Otherwise, f.f. Error. We're going to do an exit one. And we have stdio, stdlib is what we need for. Okay. Do you want to bet it works?
Yeah.
You want to bet? Okay, I'm pretty sure we have a lot of compiler errors at first. Oh wow, it's not that much actually. Use of undeclared negate. What? Token. Oh, there's no open negate. Okay, that was easy. Token. long. Okay. So, by the way, also this is the wrong way to do it. There's a right way to do it. There's a define that I don't want to look up because I'm lazy. Oh yes. So I need to. Oh, I guess we never compiled the scanner. I was like, error messages in the scanner. We need to compile the scanner, and there's also compiler.h. This is also a very ghetto makefile, by the way. Don't do makefiles like this. Okay, we need string.h. What else? Suggest braces around. Oh, yeah, this is not the right way to do. I think there's some syntax to do this, but I'm gonna do it the lazy way, the old-fashioned way. Oh, yeah. What is this? Too few arguments to function structure. Oh. Let's see. Okay, that was not so bad. Control may reach, yes. Return. I don't know what I can return. I think there's some way to tell it that error assert will. Well, yeah, no, it will never return. So let's just do a. Okay. T equals P off.
Oh,
This
why not
should
exit?
never happen.
Why not just exit?
Yeah, it's gonna know that exit. Yeah, whatever. I'm lazy. Okay,
Is
so
that in like this block?
I don't think I need it. Actually, yeah, I don't need it. It was just because of the declaration. Because now we have whatever. It's fine. All right. So first of all, it's not going to work, but we can try anyway. Simplang. So I'm giving it. So it should give me the error message. That's good. Examples. So let's say. Wow, that looks pretty damn good. Examples. Add. What do we have here? Keyword let identity. Did we really do? Was it not? Did it say identifier? No, it said identifier. You lied to me.
Oh no, I'm talking about what you said in the tokens.
Yeah. Identifier. But so we have the keyword let, identifier main, identifier A, identifier B. Oh wait. Then what happened to this? Wait, what? Operator or? Oh, that's bullshit. Oh. Wait. Oh, see, this is why you shouldn't do this. This is stupid. Don't do things like this. Don't depend on your enums to be in the right order. Because when you change the order, like I just did, things screw up. Like now it thinks that the equals is the operator or. But anyway, because I'm lazy, I'm still doing it. So scanner. So we need to revisit this. So we have open paren, close paren. Now the equals. Here comes the not, less, plus, times, negate, plus, times, negate, logic or. And here comes the assign, and here comes the equals. Okay. There. Operator equals identifier A, operator plus, identifier B, keyword end. We can now actually run the test thing, test.py, which you call on scanner, and this simplang. Bam! All right, there's a scanner for you. Passes all the tests. Tests are not too difficult, so maybe, I don't know, you'll get a prize if you are able to make a test that makes it fail. Just say an honorable mention. That's the prize. So try tripping it up. But it looked like it works well enough. So now, first of all, I hope that helped and made it clear how to write a scanner very, very easily and quickly. Most programming languages have actually very, very simple to scan tokens. One notable exception is C. I don't know whether C++ also falls into that case, but one of the weird things about C is that the kind of token that you scan depends on types that you have defined previously. So there needs to be, the scanner kind of needs to know about defined types, but most programming languages don't have that. So next assignment. We are writing a very simple parser, or I should say a parser for a very simple subset of Simplang. Namely, we are not even looking at Simplang programs right now. We are just looking at expressions, and specifically, we're only looking at expressions that are either integers or if expressions, and they can nest, obviously. So as you can see here, an integer is a valid expression in this subset. Also, an if expression that only contains integers is also a valid expression. But also, the if can contain an if as its condition, and it contain an else as its condition. And all I want is really the main thing that you should produce is a data structure that represents the program, and I'm going to talk about that in a minute. But in order that you can see that the data structure is actually correct, you have to output it somehow. And I guess I'm going to write tests. I haven't written tests before yet for this, but I want it output in this like invented thing form. You could use a parser generator for this, like Yak, but I would ask you not to, because if you do that, you're not really going to learn how to write a parser. You're just going to learn how to use a parser generator, which is fine for most cases. But as I said, we want to unblack boxify the black box, and you're just using another black box. What I do suggest is that you write a so-called top-down parser, or also recursive descent parser, which means that you will have a parse function, which you can call parse expression, and parse expression will parse either this kind of expression or that kind of expression, depending on what kind of token it looks at. And the mechanism of that is very simple, very similar to the scanner. In the scanner, we had to look ahead one character, and here we're going to look ahead one token. So if I'm parsing an expression and my look ahead is an integer, then obviously I'm going to parse an integer expression. And if my look ahead is an if token, then I'm going to parse an if expression. And I'm going to parse an if expression by consuming the if token and then recursively parsing another expression, right? Which might be yet another if expression, or it might be an integer expression. And once the recursion is done, I should be at the then token, right? So I can actually take a look at the look ahead. If it's not a then obviously it's a parse error, because it's not part of the grammar. And then I consume it, and then I parse another expression recursively, and so on until I'm done. So that's really very simple. And the kind of data structure that I suggest you produce is a so-called abstract syntax tree, but it's really not a full abstract syntax tree, because we don't care about everything. We only care about stuff like the value of the integer, and we care about the three expressions that comprise an if. We don't actually care about the then token. That doesn't need to be in the syntax tree. If we were to write a full production compiler, we would probably also keep the tokens around, like the then token, for example. And we would also have tokens that are amended with information like where in the source did it come from, like which source file, which line, which character, so that we could then generate better error messages. But we don't care about that. So unless you feel super excited to produce a compiler that can give really nice error messages, you don't have to do that. And so what this is going to look like is, I'm just going to show you the interface of that simple compiler, or the way parser, I'm sorry. the way I would do that is you have an expression, and the expression can either be, so this is C, right? So in a different programming language, you would do it in a different way. But it would have an expert type, and the expert type would be type T. It would be either an expert integer or it would be an expert if, right? And then if it's an integer, you need to have the value of the integer, and if it's an if, you need to have the three things that an if has. So you would have again an int64 t I. And then you would have another struct that you could call, I don't know, you can't call it if because it's a keyword. I'm gonna call it expert. And it would recursively, right, have another, let me do this nicer way. You can do in C. Type def on the struct is not even declared here. The condition, and you would have consequent and alternative. Right. Again, if you're writing any other language than C, don't use unions and stuff. This is a very C-ish thing. Use whatever your programming language provides. You could use in OCaml, in a functional programming language, you would use discriminated unions. In C# you would use, or any object-oriented programming language, you would use subclasses and stuff like that.
Two questions.
Yeah.
The size of this thing, is it going to be a constant? And is the size of the expert T, is that a constant?
Why would it not be a constant?
Because, I mean, depending on what the expression is, you either access the I.
Oh, but the compiler doesn't know about that. The compiler has no conception of the expert type being in some way related to which parts of the union you access. So it always gives you the largest one. Like, this is always going to be larger than this. So the union has to be as large as the largest element. Oh yeah, and then obviously you're going to have a function parse expera, which in my case it would take a context and it would return an expression. And this is your assignment for the next week. And if you have any questions, feel free to ask. Anything else we should talk about? All right. Cheers.